Now let us see this next question. So many properties of fluid are required in a single problem. A tank with a square base of area 1 meter square is divided by a vertical partition in the middle. The bottom of the partition has a small hinged door of area 20 centimeter square. The tank is filled with water on one compartment and an acid of relative density 1.7 in the other, both to a height of 5 meter. इथे प्रॉब्लेम मध्ये करेक्शन करून घ्या. तिथे 4 मीटर झालं तर 4 मीटर प्रमाणे एकही आन्सर टॅली होणार नाही, तिथे 5 मीटर पाहिजे. सो देयर इज अ करेक्शन ऑफ हाईट 5 मीटर. व्हॉट इज द फोर्स नेसेसरी टू कीप द डोर क्लोज? डॅमची जी काही अरेंजमेंट असते वॉटर डॅमची, तिथे अशा प्रकारची थिअरी आपल्याला यूज करता येऊ शकते. So the situation and the given quantity are like this. Without figure we cannot understand the problem. So the arrangement is like this. This is a tank. Filled with water. Like this. At the middle means this half point. There is a partition here, and that partition has a door. D for door. This is the say shutter. Door. So if the door opens on this side, then this compartment has a liquid having higher density. So on this side there must be acid because its relative density is more than water, and on this side there is a water. If on both sides there is a water, then the door will remain closed permanently. If acid is on this side, means higher density liquid is on this side, lower density liquid is on, then the door will open in this direction. So door open from higher density to lower density like this. So this height is h. Height of the acid and liquid column are same like this. So this is P acid from this side and P water from this side. So they are unequal because of density, because pressure is equal to H rho G. So height is same but density are different, and therefore there is a pressure difference, and that pressure difference is necessary. Now what to keep the door closed, and therefore what to apply the force in this direction. So a required force, like our situation, the required force is in this direction. This A is a area of the, so given quantity is like this. A is equal to area of the door, and that area is given 20 centimeters square. Area of the door is equal to 20 centimeter square, that is equal to 20 multiplied by 10 into minus 4 meter square. हा तो एरिया था. बेस एरिया महत्वाचा नाही आपल्या दृष्टीने. So then on one compartment there is a water and there is a acid. So density of water is equal to 10 into 3 kg per meter cube. Relative density denoted by sigma. So sigma acid is equal to 1.7 is equal to density of the acid upon density of the water. Therefore, density of acid is equal to 1.7 multiplied by density of the water. So 1.7 into 10 raised to 3 kg per meter cube. G, we will require G. So G is equal to 10. G 10 घ्यायला सांगितलेलं आहे. 10 meter per second square. And required force F is equal to question mark. PA is equal to pressure due to the acid column. A for acid. Pressure due to the acid column on door, and it is equal to height of the acid column multiplied by density of the acid multiplied by G. So this is equation small a. PW is equal to pressure due to water column. W for water column on door. So PW is equal to H rho W into G. This is equation B. Height दिलेली आहे आपल्याला. Height H is equal to 5 meters. आपली height साठी criteria लिहिली. Height H. इथे आपण करेक्शन केलेली 5.0 मीटर. This point is important. Since rho acid is greater than rho water, therefore P acid is greater than P water. Therefore dP is equal to pressure difference on door, which will keep it open as shown in figure, from higher density to lower density. Therefore, F is equal to force required this pressure difference dP is equal to P acid is more minus P water is less. Therefore, this is equal to H into rho A G minus H into rho W into G. So this is equal to H common G common into bracket of rho acid minus rho W. This is dP. This is equation 1. If F is equal to force required to keep the door closed, then F is equal to pressure difference on door multiplied by area of the door. Area of the door. Therefore, F is equal to pressure difference dP multiplied by area. So this is equal to H into G into density of acid, density of water multiplied by area of the door. Base का area क्या काम आता नहीं? अलग से. So substitute. H is equal to 5 meter. G is equal to 10 into 1.7 into 10 raised to 3 minus 10 raised to 3 and area is equal to 20 into 10 raised to minus 4 meter square. So calculations are like this. This is equal to 50 multiplied by 1.7 minus 1 into 10 raised to 3 multiplied by 2 into 10 raised to 1 into 10 raised to minus 4. 120 मिलता. So 3 plus 1 4 plus 4 minus 4 10. So 50 multiplied by 0.7 multiplied by 2 is remaining. So 50 into 2 100 100 multiplied by 7, that is equal to 70 Newton. So this much force is required, 70 Newton. The force required to keep the door closed is equal to 70 Newton. So therefore 70 Newton means the correct choice is C. C is correct. C is correct. So see the arrangement. This is a partition which has door at the bottom. This is the door. So there are two different liquids having different density on the two sides. So on one side this is acid having higher density than water. Therefore this pressure PA is more on the door than pressure on the of the water column. So this excess pressure is in the direction. So door will open from left to right, from acid to water in our figure. So but to keep the door closed, so we will require some force F. So F is the force required to keep the door closed, and it is given by pressure difference on the door multiplied by area of the door. So pressure difference is given by pressure on acid side minus pressure on water side, and this is the usual formula H rho G. So density difference is important to open the door, and if we to keep the door closed, we require some force, and that force is equal to 70 Newton, like this. Next, question number 29. So I will read the question. If the pressure at half the depth of the tank is equal to 2/3 the pressure at the bottom of the tank, then the height of the water column in the tank is atmospheric pressure is equal to 10⁵ Newton per meter square or Pascal. Atmospheric pressure दिलेलं म्हणजे त्याचा यूज आपल्याला करायचा आहे. So situation is like this. This is the water tank. The liquid is filled here. So this is the half of the height. H1 is equal to H by 2. So this is point A. This height is H2. Is equal to H this point is B. So at point A the pressure is P1, at point B the pressure is P2, and H is the atmospheric pressure. So we have to find H. H is equal to, question now, capital H is equal to atmospheric pressure is equal to 10⁵ Newton per meter square. Let P1 is equal to pressure at point A at depth H1 is equal to H by 2. P2 is equal to pressure at point B at depth H2 is equal to H. Therefore, this P1 is equal to capital H plus H1 rho G. This is water, density of water. This is water. The water की density अपना लगे. Rho W is equal to 10⁵ kg per meter cube. G is equal to 10 meter per second square, etc. So this is the question 1. P2 is equal to atmospheric pressure H plus H2 into density of water into D. This is equation 2. Like this. Given P1 इथे नक्कीच प्रेशर घेऊन असतं कारण हाईट वाढली की प्रेशर वाढतं. P1 is equal to 2/3 of P2. Therefore H plus H1 rho G is equal to 2/3 times H plus H2 rho W into D. 3 इकडे गेलो. So 3 into bracket H plus H by 2 into rho water into G plus 2 into H plus H into rho W into D. So 3 times H plus 3 by 2 times H rho W G is equal to 2 times H plus 2 times H rho W into D. So this 2H is transferred on this side. So 3H minus 2H is equal to H common, rho W common, G common into bracket 2 minus 3 by 2. This 3 by 2 will become minus. And therefore capital H is equal to H into rho W into D multiplied by, this is 1/2. Therefore height H is equal to 2 times H upon rho W into G. This is equation 3. So ही value आपल्याला calculate करायची आहे. And therefore H is equal to 2 multiplied by 10 raised to 5 upon density of water 10 raised to 3 multiplied by 10. So 2 into 10 raised to 5 into 10 raised to minus 4, so that is equal to 20. So height h is equal to 20 meter. So the correct choice is C. C is correct. C choice is correct. So here at point A, this is at half depth from the free surface is equal to इथून इथपर्यंत हा वॉटरचा कॉलम तयार झाला ज्याची हाईट h/2 आहे आणि त्याच्यावरती हे सराउंडिंग एअरचं ॲटमॉस्फेरिक प्रेशर असणार आहे. सो टोटल प्रेशर ॲट पॉईंट ए इज इक्वल टू प्रेशर ऑफ द सराउंडिंग एअर ॲटमॉस्फेरिक प्रेशर प्लस प्रेशर ऑफ द वॉटर कॉलम हॅविंग हाईट h/2 आणि बी पॉईंटला जे प्रेशर असेल ते ॲटमॉस्फेरिक प्रेशर प्लस टोटल वॉटर कॉलमचं प्रेशर ज्याची हाईट h आहे. तर हा h आपण इथे ॲड केलेला आहे. तो h दिलेला आहे आपल्याला व्हॅल्यू काढण्यासाठी लक्षात. नेक्स्ट क्वेश्चन नंबर 30. The relative velocity of the two parallel layers of water is 8 cm per second if the perpendicular distance between the layers is 0.1 cm, then the velocity gradient is equal to. So velocity gradient is given by dv by dx. So situation is like this. Suppose this layer has the velocity v1, this layer will have velocity less. So this difference is equal to, and this distance is equal to x, that is equal to this separation between the two layers is given 0.1 centimeter. So x is equal to 0.1 centimeter. dv is equal to v1 minus v2 is equal to the relative velocity difference between them is 8 centimeters per second. Therefore dv by dx is equal to velocity gradient is equal to dv by dx is equal to difference between the velocities of the two layers divided by separation between them. So this is equal to 8 centimeter upon 0.1, that is equal to 80 per second. Unit is per second. Centimeter will get cancelled, and therefore velocity gradient dv by dx is equal to 80 second raised to minus 1. Velocity gradient has this much unit. So correct answer is D. Therefore D is correct. आता विस्कॉसिटीचे प्रॉब्लेम्स आपण आता स्टार्ट केलेले. Next, problem number 31. It is again related with viscosity. In relation with viscosity, there are two important laws. One is the Newton's law of viscosity, and second one is the Stokes law. But we use both of them. This Stokes law is related with terminal velocity. It is completely different term. So we will see this 31, where we use the Newton's law of viscosity. A metal plate of area 20 centimeters square is separated from a large plate by a layer of glycerine 1 millimeter thick. The coefficient of viscosity of the glycerin is 20 poise. What is the horizontal force required to keep the plate moving with velocity 2 centimeter per second? So again I will show the arrangement by figure like this. This is a large plate. Large plate fixed. This is glycerin layer. Glycerin layer has certain thickness. This is glycerin. Glycerin layer. This is another metal plate. Movable metal plate. Area capital A. So it is moving with velocity v2 is equal to, this velocity is given, I will show some quantity in figure, 2 centimeter per second. This bottom layer is fixed, v1 is equal to 0 like this. So we know v1, v2, we can find the velocity gradient. Now the liquid has the coefficient of viscosity eta. So to move the plate in this direction, some force is required. Horizontal force F is required. What force is required to move the plate with velocity 2 centimeter per second? So coefficient of viscosity eta is equal to, it is given 20 points. ब्रॅकेट मध्ये रिलेशन दिलेलं आहे आपल्याला 20 points. So that is equal to 20 into 10 raised to minus 1 SI system Newton meter square per second. Newton second per meter square. Answer is given in Newton. Newton second per meter square. This is coefficient of viscosity. Area is given. Area of the metal plate is equal to 20 centimeter square. So 20 into 10 raised to minus 4 meter square. X is equal to thickness of the glycerin layer. Thickness of the glycerin layer is 1 millimeter is equal to 10 raised to minus 3 meter. V1 is equal to 0. V2 is equal to 2 centimeter per second, that is equal to 2 into 10 raised to minus 2 meter per second, and we have to calculate the force. The force required F is equal to, actually this distance is measured in y direction, therefore better we will denote by dy. So velocity gradient dV is equal to V2 minus V1 upon dy by Newton's law. By Newton's law of viscosity. Force F is equal to eta into E into dV by dy. And therefore, eta into E into V2 minus V1 upon dy. Now substitute the value. So eta is equal to 20 into 10 raised to minus 1. Area is equal to 20 into 10 raised to minus 4 multiplied by 2 into 10 raised to minus 2 minus 0 upon 10 raised to minus 3. So 20 into 20, that is equal to 400 multiplied by 2. This total power is 10 raised to minus 5 into 10 raised to minus 2 into 10 raised to plus 3. So this is minus 7. So 800 into 10 raised to minus 4. So 8 into 10 raised to minus 2. This much forces are required. So that is equal to 0.08 Newton. So required force F is equal to this much force is required in horizontal direction. So the correct choice is D. Therefore, D is correct. D is correct. This is Newton's law of viscosity. Next, question number 32. A square plate of 0.1 meter side moves parallel to the second plate with the velocity of 0.1 meter per second, both the plates being immersed in water. The viscous force is 0.002 Newton and the coefficient of viscosity is equal to 0.01 poise. What is the distance between the plates? The two plates मतलब separation आपल्याला विचारलेलं आहे. So these are the two plates. This separation is y is equal to question mark. This velocity difference between them is equal to one plate is fixed and other plate is movable 0.1 meter per second. This is water, viscosity of water. Density of water. So upper plate is movable. V1 is equal to 0. V2 is equal to 0.1 meter per second. And the force applied is 0.002 Newton. F is equal to 0.002 Newton, that is equal to 2 into 10 raised to minus 3 Newton. NW, coefficient of viscosity. Coefficient of viscosity of water. it is given 10 points. Again you have to convert points. Sorry, 0.01 points. So 10 raised to minus 2 points, that is equal to 10 raised to minus 2 into 10 raised to minus 1 Newton second per meter square. Unit is this. So eta W is equal to 10 raised to minus 3 Newton second per meter square. Density of water is equal to 1000, 10 raised to 3 kg per meter cube, and y is equal to question mark. पुन्हा आपल्याला न्यूटन्स लॉ यूज करायचा आहे. बाय न्यूटन्स लॉ ऑफ विस्कोसिटी. By Newton's law of viscosity, the force F is equal to eta into A into dV by dy. Therefore, dy is equal to eta into A into dV upon F. So, length of the each side is given. Length of each side is equal to 0.1 meter. A is equal to area of the plate is equal to L square is equal to 10 raised to minus 1 square. So area is equal to 10 raised to minus 2 meter square. So we know all this value. Eta is equal to coefficient of viscosity is 10 raised to minus 3. Area is equal to 10 raised to minus 2, and velocity is equal to 0.1 upon F is equal to force required is equal to 2 into 10 raised to minus 3. So 10 raised to minus 3 will get cancelled. So 0.5 dy is equal to y. Y, this 10 raised to minus 3 cancel, this will become this much meter. So 0.5 into 10 raised to minus 3 meter. So that is equal to 5 into 10 raised to minus 4 meter. तर तिथे चॉईस सी नंबर सी लेटर लिहायचं राहिलेलं आहे. So 5 is equal to 5 into 10 raised to minus 4 meter. 0.5 mm. The thickness of the water is equal to this much. Therefore, correct choice is C. C is correct. Area of the plate is not given. So each side of the square plate is 0.1. Therefore, area is equal to 10 raised to minus 2. This area. Eta is equal to 10 raised to minus 3. SI system. All the quantities. dV is equal to 0.1 meter per second. Difference between the two velocities. And required force is equal to 2 into 10 raised to minus 3. So this 10 raised to minus 3 will get cancelled. This is the answer. So the correct choice is C. Next, first we will consider 34, 33 we will see next time. The dimensional formula for the Reynolds number is, so Reynolds number R is given by Vc, critical velocity, into rho into diameter d upon eta to 0 equal. So R is simply numbered. Therefore, R has no unit, no dimensions. Therefore, dimensions of R is equal to L raised to 0, M raised to 0, P raised to 0. And therefore, the correct choice is the B. B is correct. B is correct. Actually, the Reynolds number is used is important. It is used to decide the flow, whether the flow is terminal or laminar flow. That is decided by the value of R. Knowing the value of R, we can decide what type of flow of the liquid is there. So we will see those problems next time. Okay, we will stop here.